Hello and welcome to the final video on graphs where we're looking at reciprocals, both types of reciprocals, the normal type and with the x squared. So here's the page from the workbook. Reciprocals you must have seen at GCSE, if not then it's a quick recap and then we'll get into sketching them. Now reciprocals are quite unique in terms of they have sections of the graph which are not continuous, i.e. there's gaps between certain sections of the graph. Okay, so what our job is to do in terms of sketching reciprocals is we have to find the values for where these discontinuities exist. Discontinuities mean where the graph doesn't really exist, and hence label the equations of the asymptotes. Asymptotes are lines where the graph does not exist. The point where a curve crosses or touches the x-axis should also be labelled. The Y-intercept can be found by letting x equals 0. The X-intercept can be found by making y equals 0. So this is what we have as a positive reciprocal. It will have this sort of nature. Okay, so a over x. Okay, a could be any value as long as it's positive, and what you'll notice is we've got a discontinuity here, the y-axis and the x-axis. Okay, these are regions where the curve does not cross through either vertically or horizontally. Okay, so at the y-axis this graph will go very, very close, but it will never ever touch. So the y-axis is the asymptote in this particular example, and as well as the x-axis. Okay, it will never ever touch the x-axis. So that's a positive reciprocal, and that's a negative reciprocal. Okay, so you can clearly see the flip in the quadrants. Now what we've got to do is sketch the graphs. So we've got here 2 over x. Now 2 over x will not be too difficult. It will have the same behaviour as a over x. Okay, so it's going to literally just look quite similar. Okay, let's make sure. Yep. Okay, it's going to look quite similar to this. Let's make sure my curve is a bit better here. Okay. Right, so that's going to be 2 over x, and what I'm going to do is I'm going to label my asymptotes. We've got the x-axis, but the equation for the x-axis is actually y equals 0. Okay, it's basically the line where there are no y is equal to 0, and the equation for the asymptote here is x equals 0. Okay, so those are my asymptotes for this. Now things are going to change pretty quickly now. So we've got 2 to the power, so we've got 2 over x plus 2, and we've got to sketch that graph. One thing's for sure, the graph will have the same behaviour in terms of how it looks, but the plus 2 will make an impact in where it's going to be allocated in the graph, in which quadrant, which section will go into. Okay, so we've got to just use our skills a little bit, and what we're going to do is we're going to think about the x and y intercepts. So okay, so we've got the x-intercept here of -1 and 2 over x plus 2, so we've got the x-intercept of -1. Now in terms of what this graph will look like, if you think about 2 over x, that's what the graph looks like there. When you add 2, you're basically shifting everything up by 2, all the y values up by 2. If you sort of think about it, if I substituted in x equals 1 here into this left hand side, I'll get y equals 2 over 1, which is 2. If I put x equals 1 into there though, that same x value gives me a y value of 4. Okay, so everything actually shifts up by 1. From this left hand side 2 over x to this, it will shift up by 2, sorry. So what will happen is it's going to go up, go across like that, and this graph, this quadrant, this section of the graph and this quadrant will just literally just move up. Okay, but as a result of that, the asymptote will also change. Okay, so where this y-intercept, this x-intercept is -1, just got to label that properly. Okay, so what will happen is this asymptote of y equals 0, which was for 2 over x, that will now come up, and that will be the asymptote equation y equals 2. Okay, so that's what the graph will look like, 2 over x plus 2. Now we'll come down to this graph here, C and D. So we've got 2 over x plus -1. And when I do that, 2 over x minus 1, okay, sometimes it looks like this, x and y axis. Now again, let's try and find the y-intercept. So if I want to find the y-intercept, what I can do is make x equal to 0. And what I get is -2. Okay, so y-intercept is -2. Okay. Now if I want to try and find the x-intercept, I'll make y equal to 0 and solve. Unfortunately that doesn't solve. Okay, so what we're going to have to do is think about the graph in a different way. So -2 is where the graph is now going to intercept on the y-axis. 2 over x, I mean the graph it's still a positive reciprocal, so it's not going to change in the quadrants in terms of it's not going to flip into opposite quadrants. What we've got to think about is maybe let's plot a few values and sort of see what happens. Okay, so if I had, let's say, x equals 1, for example, what would happen there? So if I put in x equals 1, I know what happens when x equals 0. Put in x equals 1, I get 2 over 1 minus 1. And you can't have that. So actually, x equals 1 is an asymptote. The graph does not exist for x equals 1. Okay, so what we're going to have is a situation that looks like this. Okay, it's going to, that section of the graph is going to look like that, and because that's the asymptote, the other section will look like that. Okay, and if you sort of think about it a bit more, what's the difference between 2 over x and 2 over x minus 1? If you sort of think about it, the graph has been shifted to the right by 1, hasn't it? Okay, this is what 2 over x looks like, and if I just move it to the right, it's going to cut the y-axis, and this section of the graph, which is here, just goes to the right, and the y asymptote also goes to the right. Okay, which is x equals 1. And the final one which we've got here is a combination of what we've already seen. We've got 2 over x minus 1 plus 3. So I'm going to do my sketch of the x and y. Now, if you remember the particular example that we had here, 2 over x plus 2, remember I said that if you got 2 over x, which was here, and if you got the plus 2 on the outside, well, what you're doing is all the y values increase by a value of 2. Okay, so similarly, if I've got 2 over x minus 1, I know what that graph looks like, then everything in terms of y will just go up by plus 3. Okay, so instead of having -2 as a y-intercept, you're going to have when you add 3 to it, you're going to have 1. Okay, and I mean this section will not really change at all. That's going to stay the same. It's just going to go up as well by 3. And originally here, the x asymptote was still y equals 0. We were still having that equation, but obviously when you move that up by 3, it's going to be an asymptote of y equals 3. Okay, this asymptote here of x equals 1, that's not going to change, that's going to stay as it is. Okay, but obviously this will shift up, and when it shifts up, when it shifts up, then we've got to take into consideration if there's any other intercepts that we need to think about. So shifts up. Okay. And obviously we've got this section here which looks like that. Okay, so is it possible to find that x-intercept? Well, let's have a look. Let's make y equal to 0. Whenever you want to find the x-intercept of any equation, make y equal to 0 and solve. Okay, we're going to subtract 3 from both sides. Multiply 3 by x minus 1, divide 3 by minus 3, and then add 1 to both sides, which is 1/3. So it will intercept at a third on the x-axis. Okay, so let's just go through sketching reciprocals. The basic reciprocal, positive reciprocal, will always have this sort of nature. If you've got a number being added on the outside, that will shift the graph up by 2, and any asymptote. So originally this asymptote was y equals 0, it's now y equals 2. Okay, and you can find the x-intercept by making y equal to 0 and solving. When you've got something like this, 2 over x minus 1, you can find the y-intercept by making x equal to 0. But when you try and find the x-intercept, it's not possible mathematically, so you have to think a little bit, maybe put in a different x value. I'll put in 1 and I've found my asymptote. I then deduce the rest of the graph. Okay, and again I learned from the previous questions, and I moved the graph up by 3 from there to there, and I found the x-intercept by doing some mathematics. You can clearly see sketching reciprocals is not as straightforward as the previous graphs. Here is the practice questions for that, and I'm just going to show you reciprocals with x squared in the next video.